Hey guys, welcome back to making a robot arm. So today what I'm going to do is continue on our coding of the three axes here. So here's code that we have from last week's lesson. So here, just our slow routine, we wrote code for the base motor, and then we said let's go through all the angles for the base motor, starting from the min up to the max, and then back the other way from the max back to the min. And then we took that and we repeated the same thing but for the extend motor. So that's what all this code here is for. So in the loop here, I don't have anything in the loop right now, but let's go ahead and run this routine, slow routine, okay? And just make sure that that works. All right, so I'm going to upload this. Just make sure it still works. Alright, so you can see both those two motors cycling through. Now if you remember, we also did something with this speed thing. So if we look back at the slow routine, inside the delay is speed, which is a variable, right? All of these delays uses speed as a variable. So we can actually set what the delay is, which will control the speed. So let's say, what is speed right now? Well, let's look up here. Let's go up. We set speed to 0. So it's basically saying if speed is 0, going back down here, it's like delay 0 between every single time we move the motor. So move the motor, 1 angle, delay 0. Move the motor, one angle, delay 0. Now that's not going to be very, that's going to be very fast because we're not delaying very long. So let's increase speed to make it slow down a little bit. And again, this is just a little review, so I'll do 50 for the speed. So it's going to delay 50 milliseconds before each movement. Should slow it down, and then also you'll be able to hear me better because the motors will be more quiet. Cool. Now it's cycling through. One way. Again, this is the base motor. And then the next one should be the extend. All right. So let's go ahead and add the kick right here, the pom-pom. You see my finger here? This pom-pom is supposed to like kick out and come back in. That's going to be the lift motor. So let's go ahead and do that. So what do? I need to copy this area, Control C, Control V, so I just pasted it, and let's change all these to lift motor. So my comment says I'm going to move the lift motor, so lift motor dot write lift motor min. And then we also want to change that to lift, and then we want to say we're going to loop the for loop from lift motor min to all the way to lift motor max, and then we want to do right to the lift motor. All right, so this is fine. Delay is fine as well. And then let's also do this lift motor max. Oops. Lift motor min, and then lift motor. All right, So now I just did the cycle through, and remember, because you might have forgotten possibly what is lift motor min and lift motor max. Well, those are values that we found in the previous lesson up here. So we already know this. We call them soft limits, like the biggest number the lift motor can be, and the smallest number the lift motor can be. All right, and while we're here, we also found the middle. We took the mid-range, the middle number between the two, which we're actually going to use a little bit later. All right, so going back to this, let's go ahead and run this code, and it should run through, and then it should we should also get the little pom-pom should kick in and out too. Let's see. And you know what? It's a little slow for me. Let's go a little bit faster. I'm going to do delay instead of 50. So again, the larger the number, slower it is. So let's do 25. So it should be twice as fast because we're dividing the delay by 2. Okay. Okay, base motor. Next, extend motor. Lift motor. And then cycle through. Okay, cool. So now we have all 3 motors going. So now let's do something else here. Typically, when we start the system, we want to go to something we call the home position. So that means, like right at the beginning, let's move the motors to like a ready position. Kind of like if you're starting a race, you want to go to that ready, set, like position before you start. And every time that you start the race, or every time that you start the arm, you want to go to that same exact spot. So that's going to be called the home position. All right. So what we're going to do is we're going to say in our loop, we want to say home position. All right, this is a function right here. Now, we haven't written what the function is yet, so I'll write that later, but it's a little placeholder. So we're going to do home position first, and then we want to do a delay. And then after that, we do the slow routine. All right, so the home position says like, get ready, go there, wait 1 second with this delay, and then do the slow routine. All right, so let's write home position, the function, like what the actual code is. So I go void home position, parentheses, and I got my curly braces. Now inside here is the code that we want. So the home position, what I want to do is I want to go to the midpoint. I want to move all of the motors to the midpoint. Now we already have the midpoint, so it should be pretty easy. So let's go here, go look up here. See, if we look up here, we have base motor mid, which is the middle, the in-between point for the base motor. We have extend motor mid, which is the in-between for the extend motor. And then lift motor mid. Sorry, here, lift motor mid, which is the in-between for the lift motor. So we just need to write the motors, all 3 motors, to go to those 3 positions. All right, so I'm going to copy this. And here we go. So inside our home position, when we call it, we're going to go base motor dot write. I'm going to paste it in, base motor mid. All right, and I'm just going to move all 3 of them all at the same time. Like zoop, it's all going to go to the home position. So base motor mid, and right away, let's do the extend motor dot write. And I believe it's called extend motor mid, like that. Okay. And then lastly, the lift motor dot write. And we go lift motor mid. All right. So at the home position, when we call this, is going to move all 3 motors to this position. And actually, more accurately, what's actually going to happen is that it's going to do the base motor first, extend motor first, and then lift motor first. And then, sorry, base motor first, extend motor second, and then lift motor third. But the commands process so quickly that it's going to look like it's going to happen all at one time. All right, so now let's upload this and check out to see what it does. All right. Interesting. I don't know if you guys saw that. My cable here got stuck. It got caught, so I'm gonna move this out of the way. So something that you guys need to kind of keep in mind too as you're doing this. I think something is kind of weird here. Seems like this is going super high, but seems like this pom-pom's going super high. I'm trying to see what's going on here. I think there's something weird about so yeah, if you're looking at this, there's something strange about why this pom-pom's going so high. So we'll kind of like look at this together, and as I'm doing this, it'd be good for you to kind of like watch it and kind of think about what is going on here. Because if it's in the middle, because mid should be in the middle of the max and min, right? So there's no reason that the pom-pom should go like way up like that. All right, so I'm gonna comment out the lift motor home position thing and see what it looks like if it looks more normal. Okay. Seems a little bit better. Yeah, there's something weird about this lift axis. Okay. So what if I comment out all of these? So get rid of the home position thing. And let's see what's going on here. So if I do that, everything seems okay. So you know what? There could be something wrong with my mid commands. So, or my base. So let's do this. for my home position, let's just move it to just move the base motor for now to the middle. So it should be like right like this, for the base motor. So let's try that. Okay. Okay, so that seems okay. You see how it went to the middle there first. So that seems okay. Now let's add in the extend motor to the extend motor mid. So this is the extend motor right here. It shouldn't do anything crazy. So let's see. I'm gonna upload. Okay. You know what? Here's another. I mean, this is good. You guys are seeing me debug real time. This is some good training for you guys. So when something weird's happening, what you want to do is you want to take out a lot of the stuff to make your program simple, and then so you can, because when things are simple, you can find the issue easier. So what I realized is like, you know what? Let's take out both of these things, the delay and the slow routine. Just look at home position. All right, so I'm gonna comment the extend motor and then just do base motor. Okay, so that's looking fine, right? Because we know the base motor, the midpoint is 90 degrees, which is like, it should look like this. So that's fine. Now the extend motor, let's look at the extend motor. So extend motor going up here, extend motor max is 150, and then the min is 180. Oh. You know what? I think I already see the issue, but let's I think I see the issue. Do you see the issue? Think about it, but I think I made a mistake. But let's first see. Okay, so the max is 150, and then the min is 80, right? So the in between there should be 150 minus. Well, I guess without even doing the math, we can just say the in between there is probably is around let's see, what, 100, 120, 100, 110, something like that. Okay, but so it should be in between there. Okay, but we'll see what happens. So let's say extend, so that's going to be this motor right here. Let me turn it. So this motor right here should go to like the midpoint. Let's upload and see what happens. Okay. So that is that the midpoint of everything? I'm not quite sure. What if I change this to max? Okay, so max would be the maximum value. We're looking at Okay, so it went all the way, this where my finger is, it went all the way over there. And then min. It went there. Okay, so the middle should be in between those two positions, but look what happens when I put mid. What happens? I think it goes even further, goes even less, like a smaller angle, which is not good. Let's see. Yeah, see, it pulled it even further. So there's something wrong. Now, I think that I caught it. Let's see if you can catch it. There's something wrong with my formula for this one, and this one, all the mid ones. So I actually, I challenge you to kind of pause it right now. This is good. Think, what is wrong with my formula? All right, so what's going on here is that this formula right here, that takes that's like this is the difference between the max and the min, okay? And then this divided by 2 takes half of that. The actual midpoint though, the actual mid angle needs to be, you take this entire thing and you add base motor min to it. Okay? So I won't go through all the math right now, but what I realize is that I messed up on the formula. Now, this one here worked earlier because base motor min is 0. So when you add 0 to anything, it's the same thing as, right? So that's why that one worked. But for these, base motor min or extend motor min is not 0, is 80. So that's why these were getting all off. So let me fix these. So I don't know if you caught that the first time, but I made a mistake. I messed up on my formulas here. Okay. So I have to add. So I have to find the difference divided by 2 and then add the. Sorry, this is wrong. Not mid. Min. Add the minimum value. All right. Here we go. So now we have it correct. We take the maximum value, subtract it from the minimum value, and then we divide that by 2, and then we take all that and add it to the minimum value. Now my mids should be correct. So I'm going to go down, and let's do extend motor mid, and it should be better this time. Won't be some crazy movement. All right, see, that looks like it makes sense now. You see this right here, right? That looks like the middle. And then let's do the lift motor. That also looks like the middle. See, before it was like all the way up here, and that was really strange because our math was off. So, big lesson today. Make sure that you double check your math when you're doing these things because your math is what controls your code, right? All right. So now we have that home position, and that looks good. So now let's put this all in, and it won't look so won't be so weird because we fixed it. All right, and I'll kind of hold it here. You can kind of see it's going through the slow routine. After it finishes, I'm going to go back to home. Okay, so it's a lot better now. So at this point, what I want to do is quickly, I want to add the stop button, the emergency stop. So meaning that when I press the button, it stops. Okay. So first I'm going to do the emergency stop that doesn't work so well, that isn't super safe, but just to review. So I'm going to say digital read, sorry, not digital read. If digital read 2 equal low, then what I'm going to do is going to say while true. So what this is a new command here, a new structure. We're saying while true, which is true is always true, do nothing. So while true, which is always, true is always true, just do nothing. So what's going to happen is just going to get stuck here on this line forever. All right. So if I push the button, it's going to go into here and then just loop in here forever. Okay. So this is a emergency stop. But what is the issue? Well, we'll see. The issue here is that if I'm already running the routine, it has to run the slow routine, the entire slow routine, before it gets finished and then goes here on to line 126 where it detects. So I can press the button, see it's not stopping. But I can keep holding it, and then it stops. See, it'll stop at the beginning of it, and then now like it's not doing anything because it's stuck there at 128. Okay, so how do I get it out of here? It's just stuck, right? Well, there's a little trick. You may have noticed on the little board here, if you look closely, there's a red button next to the barrel jack. The red button is like a reset button for your robot. So if you press that reset button, it's going to exit out of your program and then restart the computer, and then it'll work again. So press that, and then it's back. Okay. But now I'm going to try to emergency stop. Again, the emergency stop doesn't work until I get all the way finished with my slow routine. So let's just make sure it there. Okay, so let's stop there. Now, how do we get it so that it stops right when we press it? So something that we talked about before is that we need it to check for the button after every single move. So right now, it only checks for the button right here at line 126. We actually need to check for the button after every single servo motor motor.write command. So there's a quick way to do this. I'm going to write something called void emergency stop. Okay, it's a little routine, and I'm going to copy this, cut and paste actually. Okay, so it's our code that we had before. I'm going to put it inside a function, All right, why I'm going to put in the function? Because I'm going to use this code like a whole bunch of times. And I don't want to write all this, every single time. All right. So what I'm going to do now is take this and I'm going to put it. And actually, you know what? I'm going to change the name here. Let's not call it emergency stop. Let's give it some more, a better name. So I'm going to say check emergency stop. All right. So every time I call this function means I'm going to check for the emergency stop. And if it's going to check and say if the button's pressed, go into this loop and just get stuck there forever. So I will take this now, copy, and go up to here, the slow routine, right? That's what I'm running. And I'm going to paste it after every single motor.write command. Emergency stop, make sure I have my semicolon, okay. And then base motor.write, do that. Base motor.write. So right now, after every single .write, it's going to check to see did I press the button. Okay, and we can also do one after here, just in case. So after, we'll put it right there. Now, why don't I do this? Why don't I put it here, and put it there? Now I could do that, but the reason I don't need to do that is because all three of these commands, the .write commands, like happen super fast. So it's almost like these three will almost like run at the same time. So I can just do one of them right after all three run, and that'll be good enough. All right. So now I have check emergency stop after every single motor move. It should stop right when I press the button. So let's upload and make sure that works. Okay, so it's like in the middle of the move, right? And then watch this, I'm pressing the button. Boom. Stop right away. All right, and then we want to reset. Press the red button here. All right, let's move it. Let's stop it here. There we go. So now we're pretty good. So let's think of a couple challenges. Okay, so the first challenge is, we always want to write some practice ones. So this was from last time we get rid of this. So challenge 1 will be to add home position function. So we did that, and remember we've got to correct these, right? The math here. Challenge 2 is we want to add emergency stop so that it stops right away. Challenge 3, add emergency stop so that it stops right away and then starts again in 3 seconds. So it's a little bit tricky, but something that it's worth thinking through. So challenge 3 is just kind of like that bonus question. So the idea is that you're going to press the button and it'll stop right away. and then 3 seconds later, it'll start again. All right, so you can play with that. If you're not sure how to do it, no worries. We'll go over it together in class. All right, that's it for today. Have fun, and I will talk to you guys soon.